All right, guys, we're going to do activity 24, talk about surface area. So things that you'll need with you as we're going through this are the activity sheets, obviously. And then you've got the reference sheet that I've sent you. The section that we'll be focusing on is the formulas for volume and surface area. And then also you might want to have the printable pack for the nets for different shapes. So printable pack that I attached there for that. One thing that'll help you understand the nets and where dimensions are like this first few pages of it are these nets that have the little flaps on there. And what those are for is to help you cut that out and be able to glue it together or tape it together, and it'll hold the shape, and that can help you do the dimensions better. So I advise you to cut some of those out and make those three-dimensional shapes. They're always helpful to help visualize what's going on. A lot easier than just looking at a net and seeing, hey, well, that's obviously makes a box, because it doesn't, necessarily, if you're not used to visualizing those 3D figures. So we're going to talk about some of these and work our way through this best we can. Uh, all right, so with each of these problems, we're going to draw the corresponding net, and then label the dimensions that are needed to calculate the surface area. Our nets don't have to be perfect to scale or anything like that. We're just going to try to get the best we can with that. And we're going to calculate that surface area. If we have to round at any place, we're going to round to the nearest hundredths, which is 2 decimal places. All right, the rectangular prism is the first 3D figure we want to find the surface area of. And I always find it helpful to draw the 3D figure as well. Rectangular prism, got a rectangle on the bottom. That's your base. And this one says that the base is a rectangle with side lengths of 4 centimeters and 8 centimeters. So that helps me to visualize what's going on. And then it says the height of the rectangle, it's 4 or 5 centimeters tall. So that's this dimension. And so that helps me to draw this picture out of that. So I'm just drawing a 3D representation of that figure. So on the net, when we look at that, we know that this is our base, this rectangle right here. This one right here is our base, and it has dimensions of 8 centimeters by 4 centimeters. This little edge right here is the height, and that's 5 centimeters. Okay. And then when you think about unfolding the rectangular box, this comes up the side. So that's like this back side or this front side here. Let's trace around it here. This side here. It has dimensions 8 centimeters by 5 centimeters. Then this rectangle is like the top of the box, which should be exactly the same size as the bottom of the box. So it's 8 centimeters by 4 centimeters. And then this piece here is the same as this side here. It's the back side of the 3D figure, and it's 8 centimeters by 5 centimeters. This side over here is the same size as the other end of the box. It's 4 centimeters by 5 centimeters. And we look at the surface area formula on that reference sheet that we have for a rectangular prism. It's the surface area is 2 times length times width plus 2 times height times width plus 2 times length times height. So I'm going to use that surface area formula. So 2 times length times width. That's the base rectangle. So that's the bottom part and the top part. That's what that part represents. Plus 2 times, and the formula in the right order here, height times width. So the height is 5. Height times width. And then the last one is 2 times length times height. Each, or LH, I think is how the formula sheet has it. Yeah, LH. Okay. So there are, and that's going to get us the width times the height is this side and this side. And then the last piece is going to be these the sides here, this side and this side. Where those coming from? Okay, so let's look at plugging in that stuff and getting the surface area. 2 times length is 8, width is 4. 2 times height is 5, width is 4. 2 times length is 8, height is 5. 2 times 32 is 64. 2 times 20 is 40. 2 times 40 is 80. 184 square centimeters is the surface area of that figure. So again, sometimes drawing the 3D figure can really help a lot. So let's look at the next one. A triangular prism that has right triangles with the legs. So what I've done is I've taken the net from this pack here, and instead of these triangles, I've drawn right triangles on the side, or attempted to do that. So right triangles on the side there, and it creates a little longer face right here. And with a triangular prism, it's not really a formula. You've just got to find the area of all the faces to do that. So if you're looking at the 3D figure, you get a right triangle going, and then here's another right triangle. It's the other end. And then you have 3 rectangles that it creates that you got to find the areas for. And this one tells us that the right triangle has legs of 6 meters and 8 meters, and the height, which would be the distance between the 2 triangles. So the idea would be if you took this particular triangle and you rotated it so that the triangles are on the bottom and the top. That's the way the formula, and then the height would be the 7. Right? 6 by 8. So either one of those, the pictures there works wonderful for this. So this is going to be 7 meters. All right. So in our net over here, we're drawing, we got a 6 by 8, and then it's 7 long there. So what we've got to figure out though is, okay, well, if this is 7, then that has to be 7. How long is this edge? Well, that edge right there matches up with this edge that's an 8. So those edge and this match up, so they got to be the same length. Well, this edge matches up with this edge. That's not 8. That's the hypotenuse of the right triangle. So we've got to find the length of that hypotenuse. 6 squared plus 8 squared equals c squared. Using the Pythagorean theorem, a squared plus b squared equals c squared. So it'd be 36 plus 64 equals c squared. 36 plus 64 would be 100. So c is a 10. So this length is 10 and this length is 10. They match up when you fold it together. All right, so now we find the surface area, or the surface area of finding the area of each one of those faces. So we have 1, 2, 3, 4, 5 faces that we have to find the area for. So the surface face 1 and 2 are the same size, or the exact same right triangle. So I'm going to find the area of number 1 and number 2 would be 1/2 base times height, so 6 times 1/2 of 6 times 8, which would be 48, and half of that's 24. And then, so 1 is 24, and 2 is also 24. So the surface area, you'll be adding those together. So 24 plus 24. So there's 2 of our faces. Let's get face number 3. That's a 7 by 8 rectangle, so length times width. That's 56. Face number 4 is a 7 by 6 rectangle. So that's 42. And then face number 5 is a 7 by 10 rectangle. So that'd be length times width again, 7 by 10. B plus 70. So then the surface area is going to add all those together. So 24 plus 24 plus 56 plus 42 plus 70. 1, 2, 3, 4, 5 faces. 216 square meters in this case, I believe is right. Yeah, square meters. Again, the dimensions are important. Make sure that you label what dimension your answer is in there. No need to round on that one. Everything worked out to be a nice integer value. All right, so number 3 is a little bit more difficult problem. We're talking about a square pyramid. So a square pyramid has a square as the base. So I'm going to draw the base. And I'm just drawing a square from a side view that has a length of 38 centimeters. So it's 38 centimeters in all directions there because it's a square. And the perpendicular height of this pyramid is 180 centimeters. So what happens is the square pyramid, you have the point that all the triangles meet at. And then the perpendicular height drops down to the center of the square. That's the perpendicular height. That is 180 centimeters. Okay. And notice there in the hint, it says that the perpendicular height is not the slant height. So the slant height is going to be how tall the triangles that lean up to the point or come up the sides, how tall are those faces? So that's the slant height. And what we've got to do is find that. In order to find that, what we do is we create this right triangle right here. Okay. And what happens, your dimensions in the net. So when we unfold this thing, the dimensions, this is how they work out, that you get a right triangle or a surface area by finding the area of all those faces and adding them up. So we got 4 triangles and a square. The square is easy. The triangles are a little bit more difficult because to find the area of a triangle, you need this length, the height, and the base out of that. So the base of those is 38, but the height we've got to find. And the way we're going to find that is when you drop this perpendicular down, that little purple line right there is half as long as the side. So what's half of 38? 19 centimeters. Okay. So, and then we know that that's 180 centimeters. That's the perpendicular height. So we can use the Pythagorean theorem, a squared plus b squared plus c squared, to find the slant height, which is the hypotenuse of that right triangle that's created right here. That was a difficult thing to see on the screen here. And my art ability is probably limited to there, but if we had this in front of us, that might help. So if you make your three-dimensional figures, maybe this could help you. So we got 19 squared plus 180 squared is equal to c squared, and that's going to get us the slant height. So on the calculator, I'm going to 19 squared plus 180 squared, and then I'm taking the square root of that answer. It's 181. So it's real close to the same, but not quite. So the slant height, this is our slant. All right. So the surface area, if you go to your reference sheet of a square pyramid, to find the surface area, it says the area of the base plus 1/2 of the perimeter of the base times the slant height. Okay. So that's how I'm going to set up here. Area of the base area plus 1/2 perimeter times slant. I know the base area would be found by length times width on the square. So that's going to be 38 times 38. And then the 1/2, the perimeter is going to be 38 times 4. The slant height we found to be 181. Working that out. So I'm just going to go to the calculator. 38 squared plus 0.5 times 4 times 38 times 181. 1,000 or 15,200. Our dimensions are in centimeters, so square centimeters is the surface area for that square pyramid. You could also find each individual face's area and add those up, but it equals the same thing because the area of each triangle is going to be the same, and the area of the base there is 38 squared, and then this would be 38 times 181 times a half, but there's 4 of them, so it ends up being the same number there. Okay. All right, let's look at a triangular pyramid with all 4 faces being equilateral triangles with side lengths of 8 centimeters. So every line in here is 8 centimeters. And that goes around the whole figure. So I went to the nets and I found the triangular base pyramid. So what that triangular base pyramid does, you got a triangle on the bottom, and it creates triangles all around it. Okay, and what we've got to find the surface area is the area of all of those. Well, the problem with that is that the area of all triangles is found by saying 1/2 base times height. You need the height of the triangles. The height of a triangle, if you look at the net, is going to be that measurement right there. Okay, so what happens when you have an equilateral triangle? So I'm just drawing an equilateral triangle. And if I drop a perpendicular down here to get that height, if this side from here to here is 8, then what that creates is a side that's 4 right there. We don't know that side, but we do know this side, because it's equilateral, that side is 8 as well. So what we have is the A and the C from Pythagorean theorem. So again, Pythagorean theorem coming back up. Yet another problem. So it's going to happen a lot when you have triangles involved. So here we plug in the 4 for A. We don't know what B is, and the 8 for C. And so that's going to be 16 plus B squared is equal to 64. B squared is equal to 48 by subtracting the 16 from both sides. And then I'm going to take the square root of 48. Should be somewhere close to 7, 6.93. If I round that to 2 decimal places, the 8 makes the 2 go up to a 3. So B is equal to 6.93. And that is the height of our triangle. Okay. So let's find the area of that triangle, and then there are 1, 2, 3, 4 of them that are the same. So the area of the triangle, 1/2. The base length is 8. The height is 6.93. 0.5 times 8 times 6.93. 27.72. And then there are 4 of them, so we'll multiply that by 4 for the surface area of this triangular prism, because they're all equilateral, so they're all the same. So times 4, 110.88 square centimeters in this case. So a lot of work in the background to find these heights and slant heights and different things for these prisms and pyramids. It's a little tough to do. Got to pay close attention. All right. Number 5, we got a cylinder. So I went to the nets packet and just copied the net for a cylinder. Remember, a cylinder's got a circle on the bottom, same size circle on the top. And then it's a rectangle that wraps around, makes the, think about the label for a can of beans or something like that. That's what you want to think about. And they said the cylinder has a height of 32 meters. So that's going to be 32 millimeters, excuse me. And the diameter of the circle, so all the way across the circle, is 16 millimeters. Okay, so if we're going to find the surface area of that, we need to find the area of the circle that's on the top and the circle that's on the bottom, and then find the area of the rectangle out of that. So when we look at the net of that, when it's unfolded, we've got a circle here that has a 16 millimeter diameter, and then we've got a rectangle here. We know the rectangle is 32 millimeters this way, but how long is it this way? So what does this edge match up to? It matches up to the outside edge of the circle. So what's the outside edge of the circle? The length of that is called the circumference of the circle. So one thing we've got to find is the circumference of the circle. So circumference is pi times diameter. So that's easy to do. 3.14 times the diameter is 16. 3.14 times 16. 50.24 millimeters. So that's this length right here. All right. And again, don't use the pi button on your calculator. Use 3.14. We're rounded to 2 decimal places anyway, so that'll help us out there. Now, we want to find the area of a circle. Area is pi times radius squared. And what's radius for a circle? It's halfway across. So for us, 3.14 times half of 16 is 8 squared. So the area of the circle is 3.14 times 64, 200.96 millimeters squared. And how many of those are there? There are 2 of those. Okay. So we got to remember when we go to do our surface area, we're adding 2 circles. And then the rectangle is going to be length times width. And our length is that 50.24. Our width is the 32 that we knew about. 50.24 times 32. Sure. 1607.68. Square millimeters. And so the surface area, we got 2 circles plus 1 rectangle with a label that goes around this can. Add those up. 2 times 200.96 plus 1607.68. 2009.6 square millimeters is our surface area. And the last problem says, okay, what is the surface area of the cylinder in problem 5 in square centimeters? All right. So our dimension that we had was square millimeters. We want to convert that into square centimeters. All right. So one of the conversions that you could do here is think about what a square centimeter is. It's a square that's 1 centimeter by 1 centimeter. How many millimeters are in a centimeter? 10. So how many square millimeters are there in 1 square, or yeah, how many square millimeters are there in 1 square centimeter? It's 10 times 10, which is 100 square millimeters equals 1 square centimeter. That's how that works, okay? So we're going to take our number, 2009.6 square millimeters, and we're going to divide it by 100 square millimeters. And that's going to give us square centimeters. 20.096. There's 2 decimal places divided by 100. So when you're trying to convert to a different dimension, think about, okay, well, how many of those are in the not square dimension, and go from there. So converting by doing that division there is what we did. All right. So activity 24, surface area.